Hello everyone, in this video we're going to be talking about the halogenation and the hydrohalogenations of alkynes. I'm not going to be focused too much on the mechanisms, just going to be talking about the regioselectivity to some extent, if it's possible in some cases it doesn't really matter. So let's start with the halogenation of alkynes. So just like you would have done an halogenation in case of alkenes, you can do an halogenation in case of alkynes where I can use some sort of X2, which is going to be typically either Br2 or Cl2. Those are the two most commonly used. You may see the I2 being used as well, but it's not as common. So suppose I'm using Br2 there, and the reagent is going to be the CCl4 there. That's going to be your solvent. Br2 is just the reagent there. So the first step is obviously going to be the formation, adding the Br onto those two carbons. And just like you would have done previously, they're going to be anti, just like this. So it's going to be after adding one equivalent of Br2, but obviously if you have two equivalent of Br2, this reaction is not going to stop there. It's just going to keep going until you have added the Br2 across those leftover double bonded carbons. So at the end of the day, you will have two Brs on both of those carbons. So if the question says one equivalent, then you would stop it where with the alkene and the two bromines there. But it's not very efficient reactions to run because even after you're making some of this alkene with two bromines on it, you would have some of the bromines reacted with that to make this tetrahalogenated compound, and it kind of doesn't really give you good efficiency. So the best way to run these reactions to have an excess of, so if I run with this excess Br2 or at least two equivalent of Br2, then I would go ahead and straight make this guy right there. So I'm just gonna make the arrow there. Excess Br2, or even it says two equivalent Br2, then you will straight make that tetrahalogenated compound there. It doesn't really matter in terms of stereochemistry because none of those carbons are going to be chiral. You're getting two bromines on each of those carbons, so it doesn't matter the stereochemistry. And the regioselectivity doesn't matter because it's the same group that's going to be, it's the same atom or same group of atoms that's going to be added onto both of those triple bonded carbons. So if I have, suppose, an internal alkyne, there's really not going to be any difference in terms of the products. So suppose I'm using excess Br2 there and in the presence of CCl4. So at the end of the day, you just have to make sure that you're adding your bromines onto those double bonded carbons. But you're still going to end up making a tetrahalogenated compound. So that's how it's going to look like. That's your halogenation for the alkynes. I'm going to also talk about hydrohalogenations of the alkynes as well. So hydrohalogenations means I'm going to be adding some sort of binary acids. So HX, and the typical HX that you're going to be using would be either HBr or HCl. You may see HI being used as well, but it's not as common because it's not very stable. The product that you make is not very stable and it can go back. So HBr and the HCl are going to be the most common one that's going to be used. Now, this particular one does do Markovnikov addition. So if you recall, what was the Markovnikov's addition, where we know your electrophile or your hydrogen goes to the carbon that has more hydrogens to begin with. So I know I'm going to be adding the hydrogen and your halogen onto those pi bonded carbons. Now the question is, where does the hydrogen go and where does the halogen go? So remember, in this first example, I got this hydrogen on the first carbon, and on the second carbon there's no hydrogen there. So at the end of the day, when I add my first HBr, so I'm just gonna do first HBr, so I'm gonna be having the Br added here, and you're going to have the hydrogen added here. And remember, there was already a hydrogen there, so don't forget that either. But then in the next step, what's going to happen, you will have the second equivalent of HBr being coming in. Now, where that's going to get added? Well, again, that's going to be getting added onto this first carbon as far as the hydrogen go, because that first carbon is still going to have more hydrogens to begin with. Now, as far as the mechanism go, this goes slightly different mechanism than what you would have seen in case of uh, uh, hydrohalogenation of alkenes, because in that case you're making a carbocation. Here, if you try to do that, it would make a vinyl carbocation, and they're not that stable. So they run a slightly different mechanism, and I'm not really going to focus too much on that, but make sure you know that it's going to be a Markovnic oxidation where the hydrogen needs to go to the carbon that has more hydrogens to begin with, in this case the first carbon. So then at the end of the day, I'm not really going to draw out the hydrogens now. Both of those, your halogens, are going to be on the same carbon. So now you're making a geminal carbon. So remember, we have talked about how you're going to be making vicinal carbons from the halogenations of alkenes. And I said in one of those lectures earlier, the geminal hydrogens are not geminal halogens. Dihalides are not going to be made using alkenes, but rather using alkynes, and we'll talk about those later. So this is how you're going to be making these geminal dihalides. Now, suppose if you don't have any hydrogens onto the carbons. So I can have 3 and 4 here. And to make this a little bit different, I'm going to have another carbon there so you can see that multiple products can be possible there. So not going to be a good reaction to run because you're going to have multiple products. Now, I don't know when I'm doing this HBr addition, I could have either this hydrogen goes to the second carbon or to the third carbon. It doesn't really make any difference among those two. So you could have multiple products being made at the end of the day. So one of your products is going to be where both of those bromines goes to the third carbon, so like this. And then obviously your other product, you could have both of those bromines goes to the second carbon. So you could have two possible products in that particular case. Obviously, your Markovnikov addition kind of matters the most when you're dealing with terminal alkynes. If you're using internal alkyne, then it doesn't matter a lot. However, keep in mind if you pick any one of those carbons to have the hydrogen added, like suppose in the first step, if I pick this second hydrogen where the second carbon where the hydrogen is going to be added, then I'm going to have my product or intermediate rather would be looking like this. Then you got to make sure when you add your second HBr, you are now adding that hydrogen to the second carbon, because now second carbon has one hydrogen there already, and obviously that was not in the reactant, but you got that there. Okay, so then you can do the same thing with your third carbon, and that would give you the second product there. So this is how you're going to be running your hydrohalogenation and the halogenation reactions of alkynes. If you have any questions, feel free to leave any comments in the section below.